Hello, in this video I'm going to solve question 8, problems set 2, lecture 3, lectures in elementary number theory. Determine all natural numbers x and y such that xy squared plus y plus 7 divides x squared y plus x plus y. Pause the video at this point and give it a try. Okay, so now let us solve the problem. Here I am looking for all x and y from the set of natural numbers for which the left-hand side divides the right-hand side. In other words, this number is divisible by that number. Okay, so what I want to do, I want to use the theorem that I presented in lecture number 3. These are exercises that I designed using for practicing about those lectures. So the theorem that we had in that lecture was this. If I know A divides B, if I want to, I can add any integer multiple of the left-hand side to the right-hand side. So in other words, I can, if m is an integer and I know this is true, I can conclude that this one is true and the other way around. If I have a multiple of the left-hand side as a summand on the right-hand side, if I want to, I can drop them. So that theorem was discussed in lecture number 3 on the same playlist, elementary number theory playlist. Okay, but we also had a theorem in lecture 2, if I remember correctly. If I have A dividing B, if I want to, I can only multiply the right-hand side by an integer. So I can conclude that A also divides MB. So here, the first thing that I want to do, if you have watched the videos, the previous to this video on this playlist, you have enough experience, so I will not explain that much now. So what I want to do, first of all, I want to get rid of this combination in which x and y are interconnected. Okay, so to do that, this is xy squared, this is x squared y. Okay, so what I can do, I will first multiply the right-hand side only by y using this second theorem that allows me to multiply the right-hand side of a divisibility relation by any integer if I want to. So you will see why this is beneficial. These are a little bit higher level problems, so you have to be a little bit creative. So it means that if you have done the problems regularly on this playlist, you have enough experience to tackle harder problems. So I will multiply the right-hand side of this by y. So then it becomes x squared, y squared, plus xy plus y squared. Okay, so that is possible. Okay, but be careful. This arrow is not reversible. Multiplication, the right-hand side by m is acceptable, is possible, but going backward is not possible, okay, in general. So this is not equivalent to my original problem. So this means that any solution that I get from this onward, I have to bring it back and check it into the original problem. So be careful about this point. Now you see that I want to use this theorem by giving the role of A to the left-hand side, giving the role of B to the right-hand side, and I want to give the role of M to X, minus X, sorry. So from here, I copy and paste the left, I copy and paste the right, and then I would say minus x times the left. Yes, x y squared plus y plus 7. Yes? So from here, I can go to this one. Yes? So what I am doing, I am giving the role of this m to minus x here. But why this is the case, why this is beneficial, because you can immediately see if I multiply this minus x in, becomes minus x squared y squared, minus x y, and minus 7x. At least you see that this term and that are cancelled, this and that also cancel out, and I am left with y squared minus 7x. Okay, so it becomes a little bit simpler. X y squared plus y plus 7 should divide y squared minus 7x. It might be the case that solving this new problem is simpler, but of course the price we paid is that this is not equivalent to my original statement. But that is a minority. From the experience you got so far, you know that I get a bunch of finitely many possible solutions, and then I will bring them back and check if they are working. But this problem is a little bit harder, yes, because I have a second degree on the left with the combination the next one. So I changed my strategy a little bit. So I would say that I am looking for all possibilities for all natural numbers x and y for which this one divides this one. So one possibility that guarantees this is that the right-hand side becomes 0, because we learned that 0 is divisible by any integer, even 0 in the definition that I gave you, 0 is also divisible by 0. So one possibility is to ask myself, is it possible? So because you know that this is a number, so there are three possibilities. Either this one is 0, or this one is positive, or that one is negative. So let us consider these cases separately. What about this one? Oh, sorry, this is not 4, this is 7. Let us consider them separately. What happens if this is going to be the case? So a y squared is supposed to be 7x. But be careful, we are working with natural numbers, so x and y should be natural number. So this means that the left-hand side is a complete square, so the right-hand side should also be a complete square, but you already know that 7 is a prime number. So if one possibility is that x is a multiple of 7, but a 7 times a complete square itself, because if it is just a multiple of 7, it gives me 7 to power 2, but the leftover might not be a complete square, but I want the product to be a complete square because the left-hand side is a complete square. So the only possibility for x that I can imagine that gives rise to a complete square on the left is if x has this combination where t is a natural number. But if x is this number, when I put it here, y squared becomes equal to 7 times x becomes 49t squared. And because I am looking only for natural numbers, y becomes 7t. T is the same t. So apparently, I got infinitely many solutions, infinitely many candidates for my solution. They are not still guaranteed. These are definitely solutions to this last relation, but it is not guaranteed that they are solution to my original problem. I really have to check it out. So at least I have infinitely many candidates. Any number in this form, any pair of natural numbers of this form is a candidate. But let us see if this is true or not. I have to go back and put it into the original relation. The left-hand side becomes what? Xy squared, this is x, multiplied by y squared, plus y, plus 7. This is my left-hand side. So if you don't mind, let me a factor of 7 out. So this becomes 49t to the power of 4 plus t plus 1. This will be my left-hand side. But what is my right-hand side then? So my right-hand side, I have to replace x and y here. So x squared is this power 2, which is 49t to the power of 4, multiplied by y, which is 7t. And then I will have x, which is 7t squared, and then I have y, which is 7t. Here I can factor a 7t out. So what is left here? From here, 49t to the power of 4, and from here t, and from the last one, 1 is left. Okay, so that is correct, because the left-hand side is this expression, and the right-hand side is this expression. So you see that the right-hand side is t times the left-hand side. So yes, this divisibility relation holds. So I got infinitely many pairs in the set of natural numbers that it works. So I don't need to put question mark anymore. So that is an acceptable set of solutions. So y should be a multiple of 7, and that x should be 7 of that multiple squared. It gives me infinitely many choices. All of them are accepted. But I have 2 more scenarios left. Okay? So let us see how it works. So I go back here. I had also a theorem in lecture 1. I told you that if A divides B, what you can conclude is that the absolute value of the left is less than or equal to the absolute value of the right. Okay, So if this is going to be the case, so the absolute value of the left-hand side should be less than or equal to the absolute value of this one. Okay, but now be careful. I am considering this case. So it means that I want to see if it is possible to respect this condition and still find solutions. If y squared minus 7x is positive, this is positive, so it does not need any absolute values, yes? Let me see, you can see it, yes. So I just remove the absolute value sign. So this becomes y squared minus 7x is less than or equal. Here I am looking for natural numbers, so this is definitely positive, so it does not need any absolute value signs. But this is not possible. Why? Because let me move everything to the left. So what happens? This becomes xy squared, yes, plus y plus 7 minus y squared plus 7x less than or equal to 0. Between these two, let me factor y squared out. Is less than or equal to 0. But that is not possible, you see, because I am looking for natural numbers. If x and y are natural numbers, this is definitely positive. And if x is 1, this becomes 0 plus a positive. It cannot be 0 or less than negative. And if x is greater than 1, the left-hand side is a positive number which cannot be negative. So this means that the second scenario is not even possible. It will not give rise to any solution for this, let alone the original problem. Okay? But now what about the second scenario, third scenario? Okay, sorry for the interruption. So here, the last scenario is that case, that y squared minus 7x is less than 0. So the left-hand side is still positive because I am looking for natural numbers. So let me write xy squared plus y plus 7 is less than or equal to, but now because y squared minus 7x is negative, when I remove the absolute value sign, I have to multiply by minus sign. This becomes 7x minus y squared. Okay, let us see what happens in this case. Okay, so let me move things around. So for example, let me move this everything to the left-hand side, so it becomes xy squared plus y plus 7 minus 7x plus y squared is less than or equal to 0, and see if it happens indeed or not. So what we can do here, for example, because this is the only problematic one, every other number is coming with positive sign, and because x and y are natural numbers, so the sum should be positive except for this one. So we have to see what we can do with this one. So between these two, if I factor x out, then it becomes y squared minus 7, and then I copy and paste the rest. So let me write y squared first, and then I write y, and then I write 7. Okay, I want to make it negative. Okay, if possible, of course. Y is a natural number, so this part is positive. X is a natural number, so x is positive. So the only control that I have is, if possible, to make this one negative. For example, hypothetically, if I make this negative and I make x a huge number, then of course this negative number will dominate this one somehow, and I will reach to my goal to see if it is possible or not. Okay. But if I want to make it negative, then I have some limitations because y is a natural number. I want to make this negative, so it means that y should be either 1 or 2. These are the only options available to me if I want to make this combination negative. Because if this one is not negative, these are positive, so I will not be able to reach this goal. Yes? So in order to make it negative, these are the only options that I have for y. But let us see that if y is 1, is it really possible to get a natural number x as well? So I will go to my original problem, yes? So let me clean this. So that was my original problem, you know. This is my original problem, but now I am considering y to be 1. So everywhere instead of y, I put 1. So this becomes x plus 8. Yes. So let me see if you can see that. Yes. So it becomes x plus 8 divides, and then again, instead of y, I put 1. So this becomes x squared plus x plus 1. And then I ask myself, can I find x something like that works or not? So for example, what I can do, I can subtract x times of this from that expression. So I can do it like this. I can say that if this is going to be the case, I write the right hand side and I would multiply this by x and subtract it. Okay, so I will not explain because more or less everything is as before. So let us do the calculations faster. So here, this minus x squared will cancel this one. Then I will have minus 8x plus x, which is minus 7x, and plus 1. So this is not just something like this. Okay, and then what I do, I will add 7 times this to the right hand side to get rid of this x. Okay, so what will happen then, this becomes x plus 8 divides 1 minus 7x plus 7 times x plus 8. I'm just using the same theorem that I started to describe them for you in the beginning. But now this 7x will cancel that 7x. 7 times 8 is 56, 57. Yes? So this means that from here, x plus 8 should divide 57. Okay, and then what are the options available for me? So if x plus 8 is 57, be careful, x is a natural number and it is supposed to divide 57. But 57 is 3 times 19. Okay, so x plus 8 should be a factor of 57. So this means that x plus 8 should be, because I am not allowed to choose negative values, so this should be either 1 or 3, or the next number is 19, yes, and the next number is 57. These are the choices that I have for x plus 8, because I want 57 be divisible by x plus 8. Am I right? Yes, 3 times 19 is 20, is 57. So these are the numbers, yes. But x plus 8 equals to 1 will give me x equals to minus 7, which is not acceptable. I am looking for only natural numbers. The same for this one. But if x plus 8 is 19, then it means that x is 11. And from here, x is 49. So this means that x is 11 or x is 49 if y is 1. Yes? So this means that I'm also able to find 2 more pairs. Yes? X equals to 11, y equals to 1, x equals to 49, y equals to 1. This is also 2 more pairs, which is different from the other ones. Yes? Because you know that here y cannot be equal to 1. So these are new pairs. These are not the old ones. Okay, the other scenario is y equals to 2. So let me see if I can get new pairs from there as well. So I don't need this one. I will take y equals to 2 and put it back into my original problem here. So here, instead of y, I put 2. So this becomes 4x, and 2 plus 7, 9. So remember that. And here, it will be 2x squared plus x plus 2. Okay? So I will have 4x plus 9 dividing 4x plus 9 dividing 2x squared plus x plus 2. So 4x plus 9 supposed to divide 2x squared plus x plus 2. now I ask myself, can I find any natural number that fits in this equation? Let us check. And again, the same tricks I'm using over and over again. So if this is 4, this is 2, so it motivates me to multiply the right-hand side by a 2, for example. I'm not saying that what I'm doing is the optimal way. You might sit down and think and find better ways yourself, but that is the general spirit about the problem. So I multiply this by 2, so it becomes 4x squared plus 2x plus 4. It is possible to multiply one side by an integer, and then I want to use the theorem that I will multiply this by x and subtract it from here. So it becomes 4x plus 9 divides 4x squared plus 2x plus 4, and then minus x times that expression. Okay, and if I simplify this, 4x squared are gone, minus 9x plus 2x is minus 7x, and then I have plus 4. Yes, so what is left for me is this one. Okay, and again, I multiply this by 4, so this becomes 4x plus 9 divides minus 28x plus 16. And then I want to get rid of this x, so I add 7 times of this to here. So let me go horizontally. So this becomes 4x plus 9, and I multiply this by 7 and add it here. So let us do it in our head. If I multiply this by 7, it becomes positive 28. When I add it here, it's gone. When I multiply this by 7, it becomes 63 plus 60 plus 16. It's 79. Yes? Okay, so this means that 4x plus 9 should be a natural number, so it should be 1, and 79 is a prime number, I would say, yes? Yes, so I have only 2 options. Okay, but none of them will work, as you see. So none of them will give rise to a natural number x. So in general, I was able to solve this problem completely. So I have 2 separate pairs here, and I have infinitely many pairs here of this form, in which t is any natural number. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye.